Today we're reviewing the ASUS ROG 850G Power Supply Gundam Edition. And if you're wondering what makes it the Gundam Edition, it's the fact that it comes with some kind of cheap magnets that have blue, red, and white painted on them. We're going to be reviewing this in full, though. We're looking at it for power supply quality, but also it's a good segue to talk about companies trying to do something more unique than just black and red gamer theme for every product they manufacture. This is a move in the right direction. It leaves, however, a lot to be desired on the branding side. Before that, this video is brought to you by Thermal Grizzly. Thermal Grizzly's Hydronaut and Cryonaut thermal pastes are high-performing thermal interfaces for use on CPUs and GPUs. You can bring an old card back to peak performance by repasting it and doing preventative maintenance, and Thermal Grizzly's Hydronaut is ideal for water cooling and air cooling for new and old cards alike. Cryonaut paste is one of the top-performing pastes for extreme overclocking with CPUs and GPUs, and has been used in several world record-scoring machines. Learn more at the link in the description below. So starting off, the baseline ROG 850W White Edition power supply, something like $230 on Amazon right now. This is an existing power supply. ASUS has not made a new base product for it. It has instead basically rebranded a product for a limited edition. We don't really have a problem with that. There's no reason to re-engineer the power supply proper for being Gundam themed. It really just needs a new coat of paint. However, this does not look like it is made of Luna titanium alloy, so we're not really sure how well it'll hold up to Zaku gunfire, but that's maybe a concern for another time. We are, however, a little more worried about some of the actual effort invested into the branding. For example, you get these 3 custom branded cable ties that, I mean, the quality of the print is overall good for printing on a cable tie, but there's 3 of them, which is so few that it's actually offensive at this point. It's like you're spending this huge upcharge for a collector's item on an already expensive power supply that's over $200, it's approaching $300, and you get 3? Really? That's what we're doing? Anyway, that was a little offensive to see, but they've included a couple magnets, so you get a few Gundam magnets, you get an ASUS ROG magnet, you get this thing, which is an LED plate. I think Stone will talk about this later in the video on his teardown, but this could have easily been integrated into the chassis of the power supply because the chassis is just stamped steel. It gets bent 3 times and then it gets cut, and then they screw it together with another piece of stamped steel. It's one of the most trivial possible chassis you could make on the market, and that's true for all power supplies. So rather than cutting out an extra hole for something that's getting made anyway, basically a Seasonic power supply shell, ASUS shipped out a magnet that sticks to it with an LED cable that leaves a lot to be desired in many ways, like just generally being kind of thin and cheap, but also not being particularly long. So this was not really not a fantastic implementation. We weren't too happy to see that out of box, that this is how they did the execution of a Gundam theme. However, there's a saving side of it, and we're going to get into all the technical details, the efficiency, everything in a moment. But starting with the aesthetics, since that's what they're marketing here, the saving side is the cabling. So ASUS has at least done fully custom sleeved cables. There you have blue and white for the sleeving. The cables alternate colors, and then it's got a red connector on the end of it. So this is a big upside. You do generally pay a lot for custom sleeved cables, so that's where probably most of the money went in terms of where they're pulling the additional cost on this. And that's, of course, branding, co-marketing with the IP owners notwithstanding. Now, all this said, we are really happy to see a company like ASUS, a big company, MSI, Gigabyte could jump in here too, doing something unique, trying to do something other than a black shell, maybe occasionally a white shell, or even maybe a gray and black shell if they're feeling particularly feisty, doing something different and trying to get some extra effort into the design of a PC component. But no one comes close to Yeston, which is a much smaller company that's doing things that almost seem silly because they're cat themed or themed based on in-house anime characters, from what we understand at least, that aren't featured in any kind of actual IP elsewhere. But Yeston's doing a great job of putting in all this work to make fully custom products, to custom mold and shape the shell of the product. In other words, not just painting or putting stickers on or putting LEDs into an existing thing. They're making new things that are unique. So Yeston puts everyone to shame still, and it's almost unbelievable how a company that is relatively small has been able to put forth such a strong effort that's still, by the definition of it, mass-produced. It's not like they're hand-making these things. So ASUS has a lot to live up to here with its execution of the Gundam products. They're doing okay, but it does at times feel lazy. We have two Gundam enthusiasts at the office. When I was speaking with Patrick Lathan before filming this review, he had the same thoughts of like, he said, did you see the kit that they sent with the power supply? And I said, yes. And he said, yeah, it's just basically some decals. And then Keegan said he felt like, as someone who's into Gundam products, he would be left feeling a little disappointed by what was included. And this with a very high price tag. So that's really the big heft of this and why it feels like that. Anyway, the power supply itself is important too. ASUS has done a great job on this power supply. It tested as one of the best we've looked at anytime in the last year that we started really seriously doing power supplies. So really good foot forward on the power supply quality, the power delivery, the voltage regulation. The protections are more or less good. There's one we have a criticism on we'll talk about. But ASUS has done an excellent job with the power supply itself. That's good. The rest of it, well, you know our thoughts on it. It's cool to see the difference. We're excited to see the difference. We're glad ASUS is trying to do something new. We're glad a company is trying to do some more cross-licensing, because there's a lot of cool IP out there where they could get it on other computer products and do neat things with them. We just would have liked to see a little bit more effort put into it. Anyway, we need to talk about specifications and testing. Before we start, a very important methodological disclaimer here. We always like to disclose any potential shortcomings in our testing methodology. The one for this power supply today is we did all of our testing for this review on Earth, and so we are unfortunately unable to predict or calculate how this might perform in space or in orbit of any kind. And as such, that will be a potential shortcoming if you are looking to buy one of these ASUS ROG 850 watt power supplies for maybe your mech suit. We won't be able to tell you how it'll perform once you leave Earth and its orbit. So that one, at that point, that's on you. For the rest of this, we've added some new testing. So even if you're not into the Gundam stuff, we have some additional cross-load testing that we've added this time. We're building on our power supply testing. Every review we add something new. It's pretty fun. We're learning a lot about them. And we're using all of our testing equipment to produce excellent data and learning to leverage different pieces of it to better evaluate power supplies on a purely technical level, getting deeper down into it. Talking about the specs, looking at the general specifications, this power supply checks most of the necessary boxes for a high-end unit. It's got more power than most PCs need at 850 watts, or at least the total capacity of it. It's 80 plus gold in its sticker, but we'll talk about why that's actually not true, except in a good way, in a few minutes. It's also got all the industry standard protections. There's a 10-year warranty on it, and it fits in most cases as it falls under the ATX dimensions. There are also custom ROG heatsinks inside that are pretty interesting. We'll look at those in Patrick Stone's teardown in a moment. For power delivery, the unit can produce almost all of its rated output on the 12-volt rail alone at 840 watts. That's good. And the standby rail is fairly standard at 3 amps for 15 watts output, which will work well if you have an always-on USB port for charging mobile devices. The 3.3 and 5-volt rails are both rated for 20 amps and a combined 100 watts. Like most modern power supplies, it will work on just about any power grid, as it accepts 100 to 240 volts AC at anywhere from 50 to 60 hertz. Enough of that, let's get into the teardown, then we'll talk about some more of the testing numbers.
Welcome to the engineering bay. Today, we've removed the core of a Gundam unit, and we're going to use it to help train you, engineering recruits, so that you can field repair Gundams in combat. Now, this is an ASUS PSU, and it is supplied by Seasonic. It's from their Focus Gold series, and it's got a couple of differences. We'll look at those as we dive into it. So we'll start by lifting this top piece off. It's just your standard C-shaped shell. Nothing too crazy about that, and that'll bring us to the inside. So we'll start the analysis of the components right here at the back. This is the beginning of the EMI transient noise filter. It's just a mini PCB here. If you could look from the top here, we've got, let me grab something real quick. This is my trusty non-conductive specialty pointing device. It does well to contrast against the black materials inside the power supply. But we've got two little blue capacitors here. These are Y caps, and then on the bottom of this PCB, you can see just peeking out here a little gray X cap. And then at the base of this PCB is a discharge IC, which makes it safer for people like me who are taking power supplies apart to work on them. That being said, always be extra careful because you shouldn't just trust the discharge IC did its job. Much better to grab a voltmeter and check the capacitor, especially the bulk cap, to see if it's got 0 volts charge on it. That being said, don't open power supplies if you don't have to. There you go. So moving along, we just moved down this wire here onto the main PCB, and you can see that that brings us to some more of the EMI transient noise filter. Specifically, we got this 15 amp 250 volt fuse and an MOV right here. These both are going to help with surge. And then as we move down, we've got two big chokes here, the common mode chokes, and then a couple more Y caps and another X cap. This one screw hole we want to make a comment about that this is a stone slip of the screwdriver, so this is not manufacturing defect. This is actually what happened when I was taking this thing apart and I missed the screw and hit the PCB. It kind of scratched the PCB. The rest of it is on the side of the PSU, so I'm going to swing that around this way here and shift it up. We have an NTC thermistor, which helps to limit inrush current. And then to bump efficiency, that NTC thermistor gets pulled out of the equation with a bypass relay. We'll try to work on the name pronunciation here. This NTC thermistor is by Songtian, and the bypass relay is by Hongfa. Maybe Hongfa? Anyway, I'm going to try to get better at that as we go. And that wraps up the EMI transient noise filter. From there, we're going to move on to the conversion part of the system, which starts with a pair of full bridge rectifiers. So one of them is right here on this side of this heatsink, and the other one is on the opposite side of the heatsink right there. These guys are both glass bridge rectifiers. They're GBU 15JLs, and they're good for 600 volts and 15 amps. From there, the rest of the APFC boost circuit is made up of, if we flip this over to see the bottom, a Champion 6500 UNX, which is the PWM controller for the APFC, and then the APFC MOSFETs, one here, and the APFC diode, which if we bend this guy back, you can see more clearly right there. The APFC MOSFETs are Infineon IPA 60R190P6s, and the diode is a Cree 3CD 08060. And then the last piece of that APFC boost circuit is, of course, the bulk cap right here. I should also mention this big inductor. That's certainly part of the circuit. But the bulk cap is another piece worth mentioning, and it can do 820 microfarads at 400 volts. It's rated for 2,000 hours at 105 degrees C. To finish off the primary side, we have on the bottom, once again, right over here, a Champion 6901 T6X LLC resonant controller. And that switches a set of 4 Infineon MOSFETs. They're exactly the same model as what we saw in the APFC part of the circuit, and they are in a full bridge configuration. Maybe we can get a look at these with the camera, maybe not. There is one right here, and then there's another one right here. And then on the other side of this heatsink, I guess we'll just have to imagine this. Maybe we got some ridiculous camera work, lighting, etc. But there's another one right here at the end of this pointing device, and then another one right in there. So 4 of them, which makes sense when you talk about a full bridge rectifier. As we move on from the primary side to the secondary side, the isolation transformer is this guy right here. So just beyond the transformer, we have this set of heatsinks. And again, these heatsinks are something you'll find on this ASUS power supply, but not on the Seasonic Focus Gold series. And these heatsinks are specifically for the plus 12 volt DC to DC rectification. That is being handled here on the bottom by these 4 MOSFETs. Those MOSFETs are an Xperia PSMN1R4-40YLD MOSFETs. And if we flip back to the top side, we can then see the 5 volt and 3.3 volt DC to DC switching and the regulation as well. This is all done on this sort of PCB sandwich here. What you can see are some caps, some chokes or inductor coils, and what you can't see are the DC to DC switching components inside this PCB sandwich. What you're missing on here are 4 Nexperia PSMN 4R0-30YLDs per per voltage. So you got 4 of those for the 3.3 volt, 4 of those for the 5 volt, and then each of those sets is being controlled by an Anpec APW 7159C. While we're here, let's jump back onto these caps. What you're seeing here are conductive polymer caps, and we counted something like 27 of them on here, and they're almost all made by FP Cap. You got some here, you got a little set of 4 of them down here at the very bottom. And then as we turn it around to the front to look at the modular connectors, you can see a whole bunch of them here. So, like I said, 27-ish, maybe more, maybe less, probably more. And then if we go to the aluminum electrolytics, you can see there are a few taller ones here, and then on the front, we got another few big ones here, and then there's some smaller ones here, and then there's some smaller ones around the 5 VSB. We'll get to that 5 VSB in just a second here. Most of the aluminum electrolytic capacitors are from Nichicon, and then, like I said, most of the conductive polymers are from FP Cap. To finish off things on the bottom side of the PCB, there's one more thing we want to point out. That's a well trend. This is basically a protections IC. It's a WT7527V. And then if we flip back to the top side, the last thing they point out here is this little 5 VSB circuit. Probably the most interesting thing in the 5 VSB circuit is the controller. It's the pretty standard EM8569C from Excelliance. Back to you, Steve.
Efficiency brings us a surprise on the ROG Strix 850-watt Gundam power supply. The power supply is badged and branded with an 80+ gold label, but the official 80+ report certifies it as an 80+ platinum, and we'll try to validate that. ASUS is still working on creating thermonuclear pulse thrusters for this line of power supplies, so as of now, efficiency is limited to what can be achieved with more traditional means, but those traditional means are working pretty well. We'll open up with a bar chart to show the comparison between our results and the 80+ testing. The GN Lab testing results verified the 80+ report for the power supply, meaning that our data also qualified the unit as 80+ platinum, not gold. It's better than they advertised. That's weird. We don't normally see that. Throwing the 80+ gold bar on the chart provides a view of just how far above the gold mark the power supply landed. And remember that even though the numerical changes in these percentages look small, it's increasingly difficult to improve the efficiency once you're at this level. The 80+ platinum, 80+ result, and GN Lab result bars stay closely clustered for every load level, indicating that this unit was probably designed to hit this rating, and the manufacturing quality is likely to be more or less consistent. No word yet, though, on whether the super deformed version will achieve the same quality levels. Next up are the traditional efficiency curves, primarily useful for indicating where the power supply hits its minimum and maximum efficiency. In this case, the peak is 92.2% at both 40 and 50% loads. After 50% load, there's a gradual slope down to just below 90% efficiency. The minimum efficiency is in the common location, the low power load result. This data is useful, though, because it illustrates how a power supply performs when the PC is idle. At 2% load, the ROG Strix 850G outputs at 63.7% efficiency, which is below the 70% that the industry is pushing for currently. This is a nod to the fact that the power supply was designed before 2020, because it was rebranded rather than re-engineered, and 2020 happens to be when those lower power standards took effect. So we suppose they weren't applied here yet. The red curve of the 80+ test unit closely reflects our data, as previously noted. The 80+ gold and platinum specification curves allow us to see that the units clearly met the certification levels. Our data here confirms the 80+ certification of platinum and badging of gold. The Gundam Edition 850 watts struggled with power factor correction at our 2% load, which is the lowest load we test right now. It produced only a 0.75 ratio of real power to apparent power. As we increased the load to 10%, the power factor reached a more reasonable 0.975. It then hovered around the 0.99 mark for the remainder of testing. The results indicate that it exceeded the marks required for its claims of 80+ gold and certification of 80+ platinum, which are 0.9 and 0.95 at 50% load, respectively. Unfortunately, at this time, we don't have a testing method for seed factor to accompany the power factor testing. Voltage regulation is next. The 850-watt Gundam Edition nearly became the first power supply we've tested to demonstrate well-engineered voltage regulation across all rails and loads. An ideal power supply, which won't exist in our lifetimes, would produce a graph that has 0% bars for all voltage rails, because perfect regulation would mean no change in voltage. The power supply showed outstanding regulation on the 12-volt, 5-volt, and 3.3-volt rails, meeting the GN standards. It performed reasonably well on the 5 VSB output, just missing our requirement for that one. The GN standards ask for the power supply results to stay at or below 1% change across loads for 12 volts and at or below 2% change for the remaining voltages. At 12 volts, the ROG Strix 850G changed only 0.4% across all loads. That's well within the desired 1% range. At 5 volts, regulation was exceptional at 0.2% across all loads, and the results were nearly duplicated on the 3.3 volt output at 0.3% across all loads. These changes were well within our 2% limit. The results here make sense as the components controlling these two outputs are nearly identical and they draw from the same input. As we mentioned, the only regulation struggle was on the 5 VSB output. There was a variation of 2.4% across all loads, just 0.4 percentage points outside of our range. The voltage drop was just over 1/10 of a volt at 0.12 volts, which is acceptable, as it started at 5.12 volts at 2% load and it finished at 5 volts even at 100% load. Overall, the power supply showed the best regulation we've seen so far in our growing power supply test suite, and it's what we expected from a $200 plus unit. This review marks our first foray into cross-load testing. The objective of a cross-load test is to create an imbalanced draw of power between the 12 volt output and the combined 5 volt and 3.3 volt outputs. In doing so, we'll destroy the Jupiter Empire. It also will test the independence of the regulation of the outputs, but mostly the first one. If the circuits are well designed and implemented, then a large load on one set of outputs will have very little impact on the voltage level of the others. Ideally, no matter what loads are placed on the outputs, they stay as close to the 12, 5, or 3.3 volt values at which they're specified. For our testing, we placed a 12 amp load on 5 volts and 3.3 volt outputs, and 2 amps on the 12 volt output. We also placed a small 0.5 amp load on the 5 VSB output. For the heavy 12 volt cross load, we pulled 70 amps from 12 volts and 1 amp each from 5 volts, 3.3, and 5 VSB. To receive a passing result from GN, we set our standards to be no more than 2% variation from the specified output value. For the 5 volt and 3.3 volt load, the highest percent difference, or the change we saw, was 0.8% for the result on the 5 volt, and that means that 3.3 volts and 12 volt rails also passed, with both being a max of about 0.3% for the result. On the 12 volt heavy load, the biggest change we saw was again on the 5 volt output. This means it still passes easily, and the 3.3 and 12 volt rails had no problems either, notching a 0.3 and 0.4% difference respectively. Overall, the Gundam power supply tested well in our first cross-loading experiment. Crossloads are realistic workloads and represent common uses in PC builds since multiple components are often active simultaneously. This table shows our ranges for voltage ripple. As we stated previously, almost any unit is going to meet the Intel power supply specifications that ask for 120 millivolts peak to peak on 12 volts and 50 on the other 3 rails. So we're going to ignore those numbers because they're stupid. Moving forward, we'll only reference the Intel values when power supplies perform poorly, extremely poorly, so poor that they're worse than the Intel values, and bypass the very forgiving ranges. We'll focus on the 30 millivolt peak to peak and 25 millivolt peak to peak for our respective goals. For viewers considering a power supply for overclocking, we'll also just note that there's an 80 millivolt cutoff line we have at the 12 volt rail for a power supply that makes it easier to overclock, more stable to overclock. That's what we consider the breaking point for too much ripple reliably. On the active rails, 12 volts, 5 volts, and 3.3 increased from 2% to 30% loads. After that, it stayed roughly the same all the way through the 100% load. The 12 volt rail performed well, peaking at 16.8 millivolts peak to peak. 5 volts and 5 VSB had a maximum of 5.8 millivolts peak to peak, and 3.3 maxed out at 6 millivolts for its result peak to peak. These are exactly the kind of ripple results you want from a high-end and high-priced power supply, and the Gundam Edition delivers exactly like a fine-tuned mech. We're still not quite ready for thermal tests on power supply reviews. We've added a few things for this one, like cross-loading, but we didn't add thermals yet. It's definitely on our list, but for this unit, it's not going to happen today. For this unit's cooling, the design, at least, ASUS puts a 135mm axial fan inside the Gundam 850, which uses the same barrier ring design that you see on their GPU cooling solutions. It's manufactured by Everflow, and it's rated for 0.6 amps at 12 volts. The fan uses dual ball bearings for its rotational friction reduction, and we did a quick check on the fan's internals to make sure everything was as advertised, and there were no shortcomings that were obvious or obvious marketing lies in the build. So sadly, that's rare and therefore good. The only other thing that's worth mentioning here is the previously mentioned custom heatsinks that are advertised to allow the power supply to run fanless for a longer period. They are considerably larger than what's inside most power supplies we've looked at recently. Our function testing for short circuit protection verified the ROG Strix 850 Gundam Edition shut down correctly when shorted on each of its different power connectors and voltage rails. The unit responded exactly as expected and just turned itself off as soon as there was a short. In testing OCP, we ran into some high trip points. The 5 VSB rail notched a somewhat ridiculous 210% by providing 6.325 amps on an output that's rated for 3. The other 3 commonly used outputs were more reasonable. The 12-volt rail tripped at around 141%, and the 3.3 and 5-volt rails both tripped at about 135. We'd like to see more tightly controlled protection on all the outputs, with a specific focus on the 5 VSB. We're not sure why that's so far out there. For overpower protection, our unit tripped OPP at about 1197 watts, or around 141%. That's another high OPP value that could be reduced to around 130%. The saving grace on this power supply's high trip point is a set of high-quality internal components that can probably provide the excess power cleanly. That being said, we'd like to see more control just for excess safety. So that's it for the review then. This thing is genuinely a good power supply. So ASUS, good job there. It's a rare product in that Gundam-themed computer parts, other than just buying them on AliExpress through sources that don't officially license it, which is a thing you can do as well. This is the only one we're aware of that is licensed, at least the only power supply we're aware of that's licensed and Gundam themed. So if you're super into that, then there's your option. Just be aware that you're paying kind of a lot for not that much extra versus just the power supply, which again is sold as its own thing without the magnet with some LEDs in it. Yeah, there's a lot of room here to do more. Hopefully this gets the ball rolling for ASUS. And that's it for this one. Thanks for watching as always. We're excited to have reviewed a good power supply at the high end now. We haven't looked at one of these, and we've been mostly focusing on sort of exploding power supplies or power supplies that were falsely advertised and have mysteriously vanished from the market since our review. Yes, that company is gone. But they've come back with a different name. We'll talk about that later. Anyway, fun to work on that one. That's it for this. Thank you for watching. As always, subscribe for more. You can go to store.gamersnexus.net or patreon.com/gamersnexus to get some behind-the-scenes videos, especially more with Patrick Stone. He's got several over there. And we'll see you all next time.